Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about some interesting facts about quantum mechanics. So the world around us, we take it for granted, like all of it pretty much. We are so used to our medium frame of reference, so we live in the scale of centimeters, meters and hundreds of meters and sometimes kilometers as well, and this is our world that we live in. But in both directions, the world is incredibly large in the astronomical scale of light years. Looking millions of light years away, you see millions of years back in time. Incredible and weird to think about, but also if we go down into the smallest scales, we find that there is a whole universe in billions of a meter, in nanometers, even smaller and smaller and smaller, this incredible strange world. And this quantum realm, this realm of atoms and even smaller, these fundamental particles, protons and neutrons, and even them made of quarks, these fundamental particles, these don't behave in any intuitive way. So the way that we think of space and time, the way that we think of objects being in a certain place in a certain time, none of that pretty much applies in quantum mechanics. One first thing that I would like to mention is that there is this common misconception that atoms are mostly empty space, and this is a really old myth. I remember in old physics textbooks when I was at school, it was still the same thing. It was this drawing of an atom which looked kind of like a solar system. You have this atom nucleus in the center of protons and neutrons, and then around it, like going, you have electrons, and this is the picture we were given. And then there's a lot of other interesting misinformation which is fun to think about and fun to hear, but not actually accurate, which says that atoms are more. And even I, at one point, a long time ago, when I made videos, then I stopped, and then I started making videos again. Long time ago, I also made a video saying that the fascinating fact is that 0.999999999 something percent empty space. But in fact, that is a misinterpretation of what the reality is. The reality is more blurry than that. The reality is that all fundamental particles, including electrons, are actually vibrations in a field. So electrons are disturbances or waves in something called the electron field. And this electron field is in the entire universe. This field is the size of the entire universe for every fundamental particle, and all the particles are just sort of waves in this field. And for electrons are just waves and vibrations in this field of electrons. And so the reality is that all fundamental particles will all matter, really everything, everything that we see, stars, planets, galaxies, and even around us, everything is just made of vibrations in fields. That is the fundamental truth of reality. Everything is made of fields. Reality is made of fields. Unless we go even into stranger territory that reality doesn't exist at all and all of that. But there is this beautiful picture. This is the beautiful picture. So this is more accurate to the truth. The reality of the electron is the electron field. It's like the cloud around the atom nucleus. And this field tells you the kind of probability of how likely you are to find the electron in a certain place if you look for it. And that's all it is. And there is this strange property with fundamental particles that, is it the wave, is it the particle? There is this famous double slit experiment, which is incredibly interesting. The reality is that these fundamental particles are particles and waves at the same time. So it's kind of like having a coin, which is heads and tails at the same time. When we measure an electron, then we see where it is, and then it takes the shape of a particle. But it happens only when we measure it. Otherwise, the electron is a field. And in reality, it's kind of both at the same time. So only when we narrow down and point at it, then it becomes a particle. Now, another interesting idea is that with all fundamental particles, electrons, for example, if you know where the electron is, you don't know how fast it's going. If you know how fast the electron is going, you don't know where it exactly is. And this can be made some sense of if we realize that the electron truly is actually a field instead of just a particle. And this is an interesting thing to think about. And a lot of things make really much more sense thinking about this way, depending on what's your intuitive understanding of particles and quantum phenomena. But for example, when I heard about this and learned this, and I was thinking about the particle colliders, where they collide electron beams with 99.999% the speed of light, incredible speed, incredible energy. And when these particles collide and they see what comes out, what happens, what they're actually doing is not just like, imagine in your head like colliding billiard balls together or tennis balls together or something like that. It's not like that at all. If you think about it, that they're just shooting and directing fields at each other. And so these fields are vibrating, moving really fast, these vibrations, and then they in different ways, and one vibration in one field can affect the vibration in other fields. And this is a profoundly, fundamentally really interesting discovery and realization to make. Another really fascinating discovery is that fundamental particles can become entangled with each other. So you have two particles and you can move 1,000 light years away from the other, or indeed you can move this other particle to the end of the universe, to the other side of the universe. They could be millions and billions of light years away from each other, but they're still connected in this weird, mysterious way. Essentially, it's like you have a blue ball and a red ball, but these balls are in a box. And you take one box to the one side of the universe and the other box to the other side of the universe. You don't know which ball is where. But when you observe one and see, okay, the blue ball is here, then you know immediately that the red ball is over there. But there's no way that any information could be traveled this way. There is some information given to you, but it's only after the fact, and you can't use this to transport information. And this is because these are sealed in a box. When you have these two boxes, you have no idea what is in one of these boxes. Only when you look at the box, then you will see what is in the box, and you can refer what's in the other box as well. So this is a really interesting effect that happens, and there's still a lot of study going into this. Interesting to know that there are so many interpretations of quantum mechanics. So essentially how quantum mechanics is right now, we have these equations, and these equations tell us perfectly how fundamental particles behave and what they'll do and what will happen and so forth. And all that works really well, and you can do some amazing physics and math with it and figure things out about the world. But the deeper question is why? So why can we only know either the position or the speed of an electron and not both at the same time? Why is it a wave and a particle at the same time? Why these quantum entanglement interesting effects exist? Why? And in science, why questions are kind of frowned upon. But it's a serious question. So pretty much right now, everyone is just working with the equations, happy, don't ask any questions, don't ask why, just do the math, figure it out. But no one asks why. But there are many interpretations of people thinking why it might be. It's like this fundamental uncertainty, this kind of randomness that exists in the quantum world. The interesting thing is that no one really agrees as to why quantum mechanics is so strange, but people are still working on it, and little by little progress is being made. So there is also this idea of particles popping in and out of existence, these quantum fluctuations that happen, in fact, all around space. In fact, there is nothing called empty space. There is no true vacuum. If you look really closely at space itself, if you remove all the air, all the atoms, all the particles, everything away from it, there is still particles there that you can never get rid of. And these are quantum fluctuations. They are part of this space-time, this fabric of reality that we live in. They are just a part of it. So these are just some facts about quantum mechanics. Truly strange once you get into it, and I really love this feeling of strangeness that you get when you learn about quantum mechanics. It's really interesting and mind-boggling and strange and kind of exhilarating to think about how weird this world is that we live in. So I hope there was something interesting here for you. If you have any thoughts, please share them in the comments, and of course, thank you so much for watching, and take care.